Why would engineers build a dam like this? At first glance, there doesn't seem to be anything unusual. But look closely, the spillway is located away from the main dam. Why would engineers separate these two major structures? To understand this unusual design, we first need to understand how a conventional dam works. A conventional dam is generally built across a river to store and control water. As the river flows towards the dam, water is stored behind it, forming a reservoir. But during heavy rainfall and floods, the water level can rise rapidly. The excess water needs a safe way out. That's where the spillway comes in. It provides a controlled path for excess water to flow downstream. So the dam stores the water, while the spillway safely manages the excess. But in Andhra Pradesh, water presents a very different challenge. During the monsoon, major rivers in Andhra Pradesh can carry enormous volumes of water. But during dry periods, parts of the state can face water shortages. So the challenge isn't simply about having water. It's about controlling it, storing it, and moving it to where it is needed. And the Godavari is the center of this story. But controlling a river of this size creates another question. Where do you build such a massive structure? The natural riverbed in this area contains relatively loose soil. A massive structure like a spillway requires a strong and stable foundation. However, hard rock was available at more suitable location nearby. This difference in ground conditions played an important role in the final design. And this is where the unusual layout begins to make sense. Welcome to the Polavaram Project located on the Godavari River in Andhra Pradesh, India. It is a multi-purpose project involving irrigation, water transfer, drinking water supply, and hydropower generation. But what makes it particularly interesting is the way its major structures are arranged. The engineers first identified a suitable location for the spillway, where the foundation was supported by hard rock. However, this location was away from the original river course. So, instead of placing the spillway directly across the original river channel, they constructed an approach channel. This channel carries the river flow towards the spillway. The approach channel extends for more than 2 kilometers. This allows the river water to reach the spillway, even though the spillway itself is located away from the original river course. But there was another challenge. How do you construct a massive dam while the river is still flowing? Engineers used temporary structures known as cofferdams to control and divert the river flow during construction. These structures created controlled working areas within the riverbed. This allowed foundation and dam construction to continue while managing the river around the work site. But the main dam itself still has to be constructed across the river. And here, engineers faced another challenge. Seepage. Water can move through the soil beneath the dam. To control this, engineers constructed a diaphragm wall deep into the riverbed. The wall acts as a barrier and controls seepage beneath the dam. Above this foundation, the earth-cum-rock-fill dam is being constructed using a combination of earth and rock. But strong water is only the part of the challenge. The Godavari is one of India's major rivers, and during severe floods, its flow can be enormous. The Polavaram spillway is 1,118 meters long and has 48 radial gates. It is designed to handle a probable maximum flood of around 50 lakh cusecs. That's an extraordinary volume of water. And all of it has to be released safely. The scale of this structure becomes even clearer when we look at its construction. In January 2019, the Polavaram Project achieved a Guinness World Record. In just 24 hours, 32,315 cubic meters of concrete were continuously poured into the spill channel. Keeping such a massive operation running continuously required a huge logistical effort. Concrete had to be poured, transported, and placed without stopping. And this gives us an idea of the enormous scale of this spillway. Now the unusual design starts to make sense. The main dam remains across the river. The spillway is located where the foundation conditions are more suitable. and the approach channel carries the river flow towards the spillway. The cofferdams help control the river during construction. The diaphragm wall controls the seepage beneath the main dam. Each part of the project has a specific purpose. But Polavaram is much more than a dam and a spillway. Its canals allow the project's impact to extend far beyond the river itself. The right main canal is designed to divert 80 TMC of Godavari water towards the Krishna basin. This transfers water from the Godavari basin towards areas that needed it. The left main canal provides irrigation in parts of East Godavari and Visakhapatnam districts. It also supports drinking and industrial water requirements in the Visakhapatnam region. The project is designed to provide irrigation benefits to around 2.91 lakh hectares. It is also planned to provide drinking water to around 28.5 lakh people across 540 villages. The project also has another major component, hydropower. A 960 megawatt hydropower station is planned as a part of the project. The principle is relatively simple. Water moving from a higher levels towards the river passes through turbines. The moving water turns the turbines and the turbines drive generators to provide electricity. So the same water infrastructure can also be used to generate power. But the story of Polavaram didn't begin with the construction we see today. The idea for the project dates back to 1941, but actual construction began much later in 2004. In 2014, the project was declared as a national project. Over the years, several completion targets were announced and later revised, and major construction and rehabilitation works are still continuing. So, this is a project that has been evolving for generations. There is also another lesser known feature of this project. A specialized fish passage system was designed to help migratory fish move upstream through the Godavari. Among these is the famous Pulsa or Hilsa. The passage provides a route for migratory fish to bypass the barrier created by the dam and continue their natural migration. When viewed from the ground, the project may appear to be a collection of enormous concrete and earth structure. But from above, we can see the bigger picture. A main dam across the river, a separate spillway, a long approach channel, temporary structures used during construction, a diaphragm wall controlling seepage, water transfer canals, hydropower generation, and a system designed to manage one of India's major rivers. All of these components work together as one integrated project. What initially looked like an unusual dam design is actually the result of adapting engineering to the conditions of the site. The river, the soil, the underlying rock, and the enormous flood flows all played a role in shaping the design. Sometimes, the best engineering solution isn't about fighting the landscape, it's about working with it. This is JJ Beyond, signing off.